Welcome back, everyone.
Yes, you do.
Like in this activity, we have a minute, for instance. Probably
So, welcome back. So, on behalf of the Russell Sage Foundation and Princeton University, it's my pleasure to welcome you all on the live stream to the Getting Started workshop for the Fragile Families Challenge. This is part of the Summer Institute in Computational Social Science. So this project that we're doing, this was really motivated by Wikipedia. So Wikipedia is an amazing thing, and one of the most amazing things to me about Wikipedia is that all the knowledge that was needed to create Wikipedia already existed. That knowledge was available in the world. So what was needed to solve this big problem was a new way for people to collaborate. So this may make you wonder, what other big intellectual problems are there that we could solve where all the knowledge already exists? We just need new ways to collaborate. So the idea of doing big scientific collaborations is certainly not new. It's pretty common in the natural sciences. So this is the first paper about the sequencing of the human genome. This paper had hundreds of authors. So this is the paper about finding the Higgs boson. This paper had 5,000 authors. So here's what 5,000 authors looks like. Collaborating from all over the world. Okay, so if we have hundreds of biologists working together to sequence the human genome, thousands of physicists work together to find the Higgs boson, what would happen if we had hundreds or thousands of social scientists and data scientists collaborating on a project? What could we accomplish together that none of us could do individually? And what if that project was about improving the lives of disadvantaged kids in the US? So what would that look like and how would that work? That's what we're doing right now. That's what we're about to find out. So this is the Fragile Families Challenge. So it's a scientific mass collaboration that's going to combine predictive modeling, causal inference, and in-depth interviews to improve the lives of disadvantaged kids in the US. So the empirical setting that we're working in, this project builds on top of a long-running project called the Fragile Family and Child Wellbeing Study. It's a birth cohort panel study. So there are about 5,000 children who were sampled at birth in 20 US cities. There's an oversample of non-marital births. And the Fragile Families team has followed these kids and their families for the last 15 years, interviewing them at regular time periods to collect information about their lives. And sort of there's many questions that have been addressed with this study, but the sort of main motivating research question is what can be done to improve the life chances of disadvantaged kids. So this data set has already been used in hundreds of papers and dozens of dissertations. And what we're going to do now is to try to use this data in a different way. So this approach that people are doing so far, this is a great approach. They've made a lot of progress with this approach. Now we want to try something a little bit different with the same data and see what we can accomplish. So the idea of the Fragile Families Challenge is to bring together sort of ideas from social science and data science, and to try to figure out what a hybrid of these ideas might be able to accomplish on this project. And particularly, I think this is a very useful way of splitting up the way that I've seen social scientists and data scientists approach research and this kind of task more generally. So if you think about a regression equation, it's sort of y hat on one side and beta hat on the other side. And social scientists are generally very focused on the beta hats. They look at the regression, they interpret these coefficients, they see to what extent they're different than zero. And they say this is about understanding, right? That is what they think the beta hats are doing. Data scientists are much more focused on the y hats, predictions, evaluating the quality of the prediction. Can I separate out spam from not spam? Much more focused on prediction, not as much necessarily on understanding. There are some approaches that can be quite good at prediction that don't yield a lot of understanding. So clearly, though, if you think about what regression is it is both y hats and beta hats. Like maybe half of these people are missing half of the story and the other half of people are missing the other half of the story. What if we could somehow combine these things? And so that's what we're going to try to do with the Fragile Families Challenge. And we're going to do it, though, as a two-step process. So the first step is the step that's focused on the y hats. That's the step we're doing now. And the second step is a step that, and that's much more, we're going to use techniques that are much more common in data science. Then in the second step, it's going to be much more focused on building understanding, and there we're going to use techniques that are much more common to social scientists, like in-depth interviews. So again, half of this project seems very familiar to half of the people. The other half seems familiar to the other half of the people. So everyone thinks this is totally obvious. But that's the idea, is that we think the way that you can bring together prediction and understanding is through this two-step process. And what we're going to work on today is the first part of that process. So let me explain more about how this works. So this is the Fragile Family and Child Wellbeing Study as a social scientist might look at the data. So there are different waves of data collection. So these families are interviewed at birth when the kid is 1, 3, 5, and 9. And then there are different types of data that are collected at each time point. So the mother is interviewed, the caregiver is interviewed, the father, an in-home assessment, and so on. So this data from birth to age 9 is now available to researchers. There's also data from when the kids are 15 years old that has been collected and is sitting on the Fragile Families team's computers, but is not yet public. So they're in the process of preparing this data to be released. And so when you see a data structure like this, when a machine learning researcher sees a data structure like this, what they see is maybe something more like this. So we have 5,000 families, and when you add up all the variables that are collected, you have 12,000 of what they would call features, or what social scientists would call variables. So this is actually a very high dimensional data set. When I show this picture to people who use the Fragile Families data, they are very surprised that there are that many variables. Often I would say the community uses a very, very small subset of these variables, and there's potentially lots of information in the others. Or maybe not. We don't know. So this age 15 data is now collected, but is not yet publicly available. And so when you see something like this, this looks like a setting where you can use the common task method. So what we do is for 6 key outcomes, and I'll tell you what those outcomes were in a second. These were selected by domain experts for variables that we think are particularly important for advancing the study of these families. So we have released some training data. So these are some of the age 15 outcomes for some of the families. And then we have some test data that we have not released that we are the only ones that have. And in fact, we haven't even looked at this data. And so then the challenge is to use whatever statistical, machine learning, social science, data science, anything you can imagine to understand the relationship between these things and figure out what is in this box here. Okay? So the outcomes that we're going to use, there are going to be 3 continuous outcomes and 3 binary outcomes. So the continuous outcomes are GPA, which is grades in school, grit, which is a psychological measure. We'll talk about more in a second. Material hardship, which is a measure of experienced poverty. So this includes things like having had your electricity shut off, or not having gone to bed without having enough to eat, things like that. So it's different than poverty. Poverty is based on sort of financial measures. This is more like an experienced form of poverty. Then there are also these binary outcomes. So eviction, whether you were evicted from your home, like kicked out of your house, whether there was a layoff of the primary caregiver of the child, and whether the primary caregiver enrolled in a job training program. Yep?
You're talking about resiliency when you talk about grit?
Grit and resiliency are related, and I'll say exactly what the survey questions are that measure grit in a second, because grit is a concept that is hard to define, and there are some debates about how one would define that, and we have defined it in the way that the Fragile Families research team defined it when they collected the data, and I'll show you what that is. Yeah?
So it seems that the continuous ones are about the child, and the binary ones are generally about the family or caregiver situation. Is that
That's a good way of describing this. That is not the intention. That is, material hardship is kind of about the family too. But I'll tell you in a second why we have some continuous and some binary. Basically, how we're going to use the predictions is different. Yep.
So some of these measures seem to be already aggregates of finer measures. Will we have access to the finer measures setting up these constructs, or?
Yes, this is a great question. So in the training, in the year 15 data for material hardship, you will not. We only release the aggregate. But in the birth to year 9 data, you will have access to some of the finer measures. But in general, this is an important thing about a lot of social science data sets, is that some of the things we care about are measured on scales. And so you'll see a bunch of individual measures, and then you'll see an aggregated scale from those individual measures. So for those of you who aren't used to working with social data, if you're going to create some kind of machine learning model, you probably want to know that a bunch of these things together are already aggregated into one variable. And we'll talk a little bit more about that later. Okay, so what is the Fragile Families Challenge? As I said, it's this two-step process. First, we do this common task method, where and I'll say more about what that is in a second, and then we're going to use the submissions to do cool stuff in step 2. So first, step 1, what is the common task method? So we all agree on a common data set, a common metric, and work towards that goal. And then the evaluation is all based on held out test data. So you upload your predictions, and those get compared to the held out data, and that's how we decide how well that contribution is doing. So this method is not new. This method is widely used, or not somewhat widely used, in machine learning and computer science. And there's this recent paper by David Donahoe, the 50 Years of Data Science paper, which I talked about on the first day. He calls this the secret sauce of machine learning. So then what we're going to do, though, is a little bit different than this standard common task method. So a lot of times, the common task method, people submit models, and you pick the one that works the best. And what we're going to do is different. So let's imagine this is a social science thing. We're trying to predict GPA. And let's say this is my model for predicting GPA. And this is Ian's model. And this is Yo-Yo's model. They're all different models that take some inputs and predict GPA. And so let's imagine we've all created our models. And then I think the most common reaction in social science is just to ignore each other's models, more or less. It's not totally true, but it's not totally false either. Then I guess the second and most common reaction would be to fight about our models. And I would be like, Ian, my model is better than your model. And Ian would say, no, my model is better than your model. And we're not going to do that. So what we're going to do is we're going to do something different, which is that we're going to combine all the models together into a community model. And so rather than try to pick the best model, we're going to try to combine them all into a single model. And there are a number of, this is sometimes called an ensemble technique in machine learning, and there are a number of results which suggest that this community model should be better than even the best individual model. So you can think of it like the wisdom of the crowds, but like the wisdom of the crowds for statistical models, very roughly speaking. So how might this work? You could imagine, for example, a weighted average between these different predictions. So my model would get a weight, Ian's model would get a weight, and Yo-Yo's model would get a weight. And then how do we pick these weights? These weights are determined based on the data. They're not determined based on the length of your CV or where you come from or anything about you, which to me is great. We've talked before about being open to new information. So people's contribution is assessed based on, and they're combined based on the data and not based on anything else. Okay? So, yes?
What is called meta-analysis in social science?
Is what?
Is what is called meta-analysis.
Meta-analysis. So this actually does have some similarities in some sense to meta-analysis, in that what we're trying to do is get something better by combining the results of lots of different studies. So here we're trying to get something better by combining the results of lots of different models. So what's so special about this community model? So I'm really excited about this community model for a couple reasons. One is it is one way of trying to capture what we as a community think. And so it's a little bit like a market price for like a stock. You're like, that stock price is supposed to include all the information that's available about that company. There's tons of people who look for tons of information. People have different strategies for how they assess that information. And all of that gets aggregated into this one number. And so with this community model, it's the same thing. Many of us may have different, some of us may be family demographers, some of us may be communication researchers, some of us may be psychologists, some of us may do machine learning research. With this set of data, all these different approaches, this is going to be what we can do together. Also, there's the possibility that through this community model, we can potentially understand what is the fundamental limit of the data that we have. So, like, let's imagine that, for example, just I built a model. And you might say, oh, well, I don't like your model. You didn't do this, or you didn't do that, or you didn't include my favorite variable or my favorite transformation. But so what comes out of this community model is now, in some sense, everyone has had a chance to contribute and participate. And so this is, in some sense, the best we can do collectively. And we can also see to what extent there will be some limit to what we can possibly do with this data to predict these outcomes. Like, there's no way you're going to get 100% predictability. So given the level of predictability that we as an individual researcher produce, is that because we're just not good enough? Or is it because we've reached the fundamental limit? So if we have enough people working on this for enough time, we will get to see to what extent performance, like if you think about these graphs of like sprinters, like the winner of the gold medal in the 100-yard dash, right? The time comes down and then it starts to asymptote and you get this idea that like there's a certain speed that people can run. And that's kind of it. And we shouldn't expect to do faster than that. And so, like, are there fundamental limits to what we can do with the data that we are now collecting? And if we can discover those fundamental limits, then we can potentially make the case that we need more data. Right? So imagine that Sarah McClanahan, one of the PIs of the Fragile Family Study, wants to go to Congress and say, you know what? We've been following 5,000 kids, and I think we should follow 50,000 kids. So I think they'll say, well, just why don't you do 5,000? You're doing, just keep doing that. And what if she says, well, actually, we've shown the fundamental limit of performance with 5,000 kids is this, and if you want better than that, we need more. If you think about like CERN, this big particle collider or whatever in the mountains in Switzerland, it's like 20 miles long or something, or 20 kilometers or 20 miles. It's huge, whatever it is. Right? That was not the first collider they built. Like, they built smaller ones and they showed, this is it. We can't do any more if we don't build a bigger one. And then they got to build bigger ones because they showed that they had reached the limit of what was possible with the technology they had then. So my hope is that this community model will help us figure out what the limit is, and that it will make us really excited about everything that comes in the next step, because this model is not the result of any one person, but it's everyone's together. And it also removes a lot of these concerns about reproducibility and p-hacking and so on, because now there's no one researcher in control of the model. So a lot of those kinds of concerns go away as well. Okay, so what are we going to do with this community model? We're going to do two things, at least two things. One is to look for what I would call dark matter, and the second is to estimate causal effects. So let me explain these in a little bit more detail. And for a lot of these things, we have blog posts that you can read while you're working that go into them in more detail. So also all the slides are available from the Summer Institute page. So you should feel free to refer to these again while you're working. So most social science models have really not great predictive performance. So if you've been in a social science talk, you see everyone is focusing on the beta hats and the stars, and then the R squared is like down here, really small, and nobody wants to talk about that. That is the thing we just kind of conveniently choose to ignore. So why is the predictive performance of these models not very good? So I think there's a couple different explanations. So I've had this conversation a bunch with Sarah. If you ask her, I think she would say for the fragile family study, they're collecting the important variables, but it's really hard to measure them. So like a lot of these concepts are about, the relationship between a kid and his mother. And that's a complicated relationship. And so if you measure that in a survey on one day you get one result, and if you measure it a different day you get a different result. So you have a bunch of things that are just measured with error, and then you add that all up and there's just a lot of noise in the system. So if you talk to someone that does machine learning, they might say, I think it's really that you don't have the right functional form, right? You're doing these linear models, maybe you add one interaction, but really there's many more transformations and interactions you could do. And if you fit a more flexible functional form, then the predictive performance would include. That may be partially correct as well. I think a third possible reason is what I would call dark matter, which is stuff that's just not being measured now. There are important things out there in the world that we just are not included in the kinds of measurements that we make when we do surveys. So if you believe that there is some of this dark matter out there and you want to find it, how would you go about finding it? So what we want to do is we want to do in-depth interviews with the kids and their families for the ones who are beating the odds and the ones who are not. So let's say we have a kid who is predicted to have a GPA of 3.0 and they have a GPA of 4.0. So that kid, something about that kid is not well captured by all the data in the Fragile Family Study and all the different functional forms people could imagine using. So we want to go and talk to that kid and find out what's going on. How is it that you're able to have such great grades? And likewise, if we have kids who are having much worse grades than expected, everyone expects this kid to have a 3.0 and they have a 2.0. What's going on? So we want to interview kids who are doing much better or much worse than expected, or we want to interview people who have a large residual, absolute value of a residual. Okay? Then we're going to do this for the 3 continuous outcomes, so GPA, material hardship, and grit. And so one way to think about this is like machine learning in the service of in-depth interviews. So normally, when we do these interviews, the sampling is maybe a random sample, maybe it's kind of an ad hoc sample, and it makes it hard to figure out what this dark matter is. So what if we could find the kids that we think have a lot of this dark matter and interview them? That's going to make it easier for us to discover what it is. So that's one of the things that we're going to do with the community model. And again, here, the fact that it is a community model is really important because if, let's just say, Ian builds a model and finds the kids with the high residuals and then goes to interview them, you may say, well, Ian, I don't like your model. Your model doesn't have my functional form, so the kids you interviewed aren't the right kids. So having the community model means that the kids that we interview are are the right kids, but it's not that. Are a good approximation of the kids that we want to interview, or at least a reasonable set of kids that we want to interview. The other thing that we want to do is we want to use this data to estimate causal effects. Now, let me explain what I mean, and I'm going to choose my words carefully here, because this is, as for the social scientists in the room, know that this is a sensitive topic. Not eviction, actually that is a sensitive topic, but causal inference is also a sensitive topic. So let's start with eviction. So this is Matthew Desmond's book about eviction, in which he does an ethnographic study in Milwaukee of sort of the causes and consequences of eviction. And I think it argues very forcefully that eviction is a really awful thing to happen to a family. And so one of the things is, the question you might ask is, does eviction cause children's outcomes to be worse? Or is eviction just associated with worse outcomes because of some common set of awful things that lead to both? So we would like to know this for scientific reasons and also for policy reasons, because eviction is something where we could actually intervene with the policy. There are policies we could do to help prevent eviction, but are those policies going to have the effects that we think? So if there is this causal relationship, then they probably should, and if they are not causally related, then they probably won't. Now you may say, of course we should just help people not get evicted. What do we need this whole thing for? But the thing is, I could have told you similar stories about lots of other things that we could do to help disadvantaged kids as well. And we'd like to do the things that are most likely to be effective. Because we can't do everything. We're not in a world where every possible intervention is just something that the world is going to allow us to do. So making causal estimates from non-experimental data is very hard and tricky and challenging. But I think it's worth trying because if you might say, really, we shouldn't do this at all. We should do a randomized controlled experiment. Like, that's really the way we should do it. And what I would say is, before we do a randomized controlled experiment, we should try the best we can with the observational data that we have. As social science, I think we have a long track record of designing interventions that potentially have unintended and negative consequences. An RCT like this would be extremely expensive. Just to be clear, I'm not talking about an RCT where we evict people. I'm talking about an RCT where we prevent people from being evicted. So again, it's not like we're going to get a ton of shots at something like this. So if you think about like the Moving to Opportunity study, which was a large-scale social randomized experiment, that cost tens of millions of dollars. So it's not like society is going to let us do tons of these interventions. And again, there are lots of other plausible things that we could try. Yeah.
Just quickly, ballpark. How much is this study costing now?
Oh, well, so it depends what you think, how you calculate the cost. So the variable cost is almost zero.
How?
Because we haven't talked exactly about, because the cost of collecting the fragile families data is supported by other kinds of grants and projects. This is an add-on to that, and the extra expenses are some of our time, food for getting started workshops, and travel for prizes. So we haven't talked about the prizes, but so like the expenses are not huge. The software that we're using to manage the leaderboard is all open source software.
Yeah, but collecting the data.
Collecting the data, that's very expensive, but that's already happened.
Okay.
That data is here, so we should use it. Okay, so given that background about causal inference, yeah.
A couple of things.
Yeah.
First of all, you brought up this business about eviction.
Yeah.
What was the punchline from the eviction? Obviously, there's some endogeneity to eviction.
Yes.
So did they solve it, or is just as a motivating example? Or?
A motivating example, I think we
Okay.
don't know.
Okay. Okay. Second thing.
There are estimates, by the way, but I think these estimates are subject to a lot of concerns
Okay.
that you might have about a lot of concerns that you might have. So there are estimates, but I don't think you would believe them.
Okay. But also, just there's a ton of papers I saw on the publications page. Have there been any causal papers out of this data set to date that have some relatively good, like regression discontinuity strategy or something like that?
I do not know. I would guess there have been some, but probably not very many. Ian might know
Yeah,
better.
there's not a lot of regression discontinuity type studies here because the community who uses the fragile families data are not like so much into that. But I think it'd be great if more people did them. But the one thing I do want to say about this is that the one main causal paper about eviction that's published uses the fragile families data, and it does a model much like the ones you'll build if you decide to predict eviction in the challenge here. And then it does sort of exactly the strategy we're going to talk about doing here. But it does it with like one researcher choosing the model.
Right.
So we're sort of taking that approach to its extreme by having everybody build this collaborative model. So
I would also say another thing about the fragile families community now is that a lot of them are interested not as much in causal questions, but in descriptive questions. We talked about that distinction a couple days ago. They want to know just what is life like for these families? There's a lot of questions like that as well.
Yeah, just to add some context, like the Fragile Family Survey is very big in social work. There's many a dissertation that uses it, but not so much about causation as about description, trying to figure out exactly the mechanisms that are at work.
Okay. So one of the things you could do is you could take the results from the community model, treat those as propensity scores that could then be used as matching. So let me explain a little bit about this idea. So matching is a strategy for causal inference and observational data. So imagine you find two people who are exactly the same, except one was evicted and one wasn't evicted. And then you could sort of make them into comparison groups if you could find lots of people like this, and then you could use that strategy to get an estimate for the effect of eviction under certain assumptions But in this data, there's 12,000 variables, so there are no perfect matches. So there are a variety of strategies that you could use. One that you could use is to create propensity scores where there is essentially you reduce those 12,000 variables into a single variable, which is someone's propensity to get evicted. You could compare two people who are equally likely to get evicted, one who was and one who wasn't. So this is called the selection on observable strategy. There are other forms of the selection on observable strategy. Some people do not like the selection on observable strategy. I am totally okay with you not liking it. Let me explain. In this case, we have been following these 5,000 families since birth. We have 12,000 variables about them. So if selection on observables has a chance, this would be a setting where it's likely to maybe work. And so what we would propose doing a lot of is sensitivity analysis. So here, a motivating example comes from public health, where smoking and cancer, that particular experiment has not been done in humans, but the observational evidence is very strong, and you can do a sensitivity analysis and you can say, there has to be some other thing out there that we are not measuring that is this big. So you, the critic, tell me what is this other big thing. I know it could be there. I'm very aware that there could be something we haven't measured, but we've measured 12,000 things here. And so if you know what this other thing is, great, tell us and we will measure it. Now, it could be the case, though, that when we do this sensitivity analysis, we figure out that this unobserved thing might not have to be that big. In which case, then we would have to conclude that we probably can't be that confident in a lot of these estimates. So I think the idea here is not to definitely make a causal estimate or definitely not to make a causal estimate. It's to take this particular strategy to an extreme and see what it can do. And if it doesn't work at this scale, then we can say, okay, Congress, we need 50,000 kids or 500,000 kids or 120,000 features or whatever we need. If we reach a fundamental limit and if we don't succeed, that is a success. And then we also want to do in-depth interviews to check this assumption of selection on observables. So in the same way that we're going to go back to interview the kids that have high residuals, we're going to go back and try to assess to what extent this is a reasonable strategy. So if we go and we interview two kids who had an equal chance of being evicted based on our predictions, and they say like, oh, I was evicted because my landlord retired. And so my landlord sold the building and then we got evicted. So that is in that case, selection on observables might seem reasonable. If they say, oh, we got evicted because I like to set off fireworks in the bathroom, then that's probably something that is potentially related to lots of other bad outcomes that we probably should have been measuring. And so maybe that's not a good case for selection on observables. So we'll see what happens. And if you want to talk more, we could talk like for hours about this, but I want to keep going. And if you want to talk more about this, you should talk to Ian because he loves talking about this. This is Ian, by the way. He's going to be with us today, helping us work through the challenge. He's part of the team that's working on designing and implementing the challenge. Yep.
On the data description,
Yeah.
I saw that there was like some contract variables which included medical data and genetics.
Yes.
Is that in our data? Or not?
No. So one of the challenges with mass collaboration is that we have to be protective of this data. These participants had trusted this data to Sarah. This process of collecting the data has been overseen by the IRB at Princeton and Columbia since the birth of the study. These people have consented to have their data being used for research, given appropriate safeguards, and we have honored that commitment to these participants, and we expect you to honor that commitment to them as well. So all of you went through the application process, all of you went through that terms and conditions. That's an important part of what we're doing. In addition to the steps that were required by our IRB, we have taken additional steps that we'd be happy to discuss with you off camera. No, I mean, obviously, that is part of being cautious and protective, is not telling everyone all the protections that you have put in place. Any other, and seriously, I would be happy to talk to you about it. So we don't have that. Other questions? So we want to use this community model, again, to look for dark matter and to estimate causal effects. And then also to enable future research, at the end of the challenge, we're going to open source all the stuff that people contribute. So all the predictions that people make, all the code that they make, and the narrative explanations that they upload. So this then becomes a source of data that other researchers can use in the future. So if we think about how we as scientists build on each other's work, we generally read each other's papers if we're lucky. But what if we could make the results of a scientific endeavor much more easier for people to pick up and recombine? So we think that by making this stuff open, lots of cool stuff will happen in the future as people work from this code or these predictions. So if you do not want to have your contribution open source, you have to delete it from the leaderboard before the end of the challenge. Yep.
So are you only collecting everybody's predictions, or are you collecting their code too? So
Both. Codes. So when you upload your submission, so today, everyone, the goal is for you to upload one submission. You will upload your predictions, and we have a file that explains the shape of that you have to upload it, because that will be automatically scored. Then you should upload your code, and then you should upload a narrative explanation, a little bit explaining what you're doing. And all of that will be used by future people. Yep.
So, two questions. First is, I and maybe some other people are only vaguely familiar with machine learning. Are you encouraging this as group or individual projects today?
So you could work by yourself or in small groups. Again, I don't think, let's just talk about this. I think a machine learning thing is going to win. Because I think a lot of social scientists have that reaction, and that's not right. Okay, so let me explain why that's not right. So if there were 5 million cases in the data, then a machine learning approach would probably work better. If there are 50 cases in the data, then a strong theory-based approach would probably work better, because there's not enough data to do all this automatic feature selection stuff, right? And so with the scale that we're working at, it seems to be the case that a pure machine learning approach is not optimal. Maybe there is a pure machine learning approach that someone else has figured out that they haven't just participated yet, but it seems to be the case that some combination of theory-based model building and automated kind of model building will likely be the best, but it could be a pure, someone goes through, deals very carefully with the missing data, deals very carefully with the feature selection, like choosing the variables correctly based on existing research. I think there's a reasonable chance that that model will do better. And again, here's a great thing. We don't all have to be taken in by the hype around machine learning. because we'll be able to compare these methods. So one of the other things that will come out of this open sourcing all this stuff is we'll get to see methodologically what are the ideas from machine learning that we should be thinking about as social scientists, and what are the ideas that really make much more sense if you're Google and Facebook and Amazon, where you have a different scale of data and a different set of problems. Do those techniques carry over into our setting? It's not clear that they do. It's not clear that they don't, but it's not clear that they do. Yep?
Just a question, in terms of time and the size and the potential complexity of what we're going to run, these models might not be done before the end of the day.
Oh, okay.
Or maybe I'm just not good enough at parallelizing things.
No, it's not. You'll see
But
the
I've,
data.
I've,
Yeah.
I've encountered neural nets that ran for a while.
Yeah, so that is not, I don't think that should be your first contribution. So what I think your first contribution should be
Maybe proof of concept.
a simple
Okay.
model that provides a good baseline.
Okay.
So if you remember last time, yesterday when we talked about surveys, I didn't say, oh, you should like do Mr. P, do the fanciest thing right away, go download the newest R package.
Okay.
No, I said you should start with the simplest thing first. That helps you get familiar with the data. That helps you make sure you understand what's going on. That provides a good benchmark for you as you go forward.
I just want to understand.
Yeah, that would be my I'm going to put some of my personal recommendations and our recommendations that we've talked about at the end so that you have a sense of how to go forward. Yep.
And are we picking a dependent variable, or are we doing all 6?
So you can do all 6 or you can do just one. Either is fine. Or you could do, some people have done all the binary ones, for example, because they're interested in binary classification. Or you could just do all the continuous ones. So the important thing is it's much more important for you to focus on something that you're excited about doing than it is to try to do everything. Yep.
Well, aside from what I'm excited about doing, are there any of the dependent variables that you would say right now have the greatest need to be tackled? Like, have people been ignoring them or anything?
That's a good question. I don't think we have a good answer for that.
They've all been tried, and people are performing better on some of them than on others. So Matt will probably show you the leaderboard, and you can kind of tell from the leaderboard like what the scores look like for different things.
And your performance metric is?
Mean squared error.
And how many people are participating roughly?
There's 350 now.
No, probably now close to 400
True,
applicants.
now close to 400, and we have 86 teams right now on the leaderboard who've submitted. So some people are participating like in groups, so the teams is less than.
Okay. And some people have already open sourced their submissions. You don't have to open source your submission until the end if you don't want. But some people have wanted to do it the whole time. So we have a collection of open source submissions that you can find on the Fragile Families Challenge GitHub page. And if you want to open source yours while it's going on, let us know and you can post it here. So how to participate. So we've gone through the application process. You all have already done that. Let me just introduce the outcome variables and then offer you some advice and then we'll get started. So the outcome variables, GPA. So the kinds of questions we would be interested in, how do some kids beat the odds academically? So this is exactly how GPA is measured on the survey. And again, this is all online, so you can come back and look at this later, but you really want to know how these things are measured. So here's the distribution of GPAs in the training data. So just, this is to give you some sense of what the outcome looks like. So grit, so there are some claims that grit is very predictive of success, possibly more predictive than IQ. One question, this is Angela Duckworth's book about grit. One question that is not clear is like, where does grit come from necessarily? Why are do some people seem more gritty than others? So again, you would want to interview kids who have high residuals. Here is how we measure grit. This was determined not by us, but by the Fragile Families research team. This is similar to the standard grit scale, but a little bit different. And again, we have details about that on the blog post about grit.
It's just these 4 questions.
Yeah, just these 4 questions. This is the distribution.
Simple
Okay.
average.
Yeah, simple average of these 4. Material hardship. What unmeasured predictors are associated with families unexpectedly escaping severe deprivation? So families that are predicted to have material hardship but don't, or the opposite. someone who's not predicted to have material hardship but does. So here are the items that make up this scale. This is also a standard scale that was developed in the
Like 80s.
80s, something
Meyer
like
and
that.
Jenks.
Yeah, Meyer and Jenks. Here's the distribution. So fortunately, a lot of people have 0, but not everyone. Eviction. So as we talked about, the question is, does eviction cause worse outcomes? This is the eviction question. One thing is that there are relatively few evictions in the data, which is, of course, a good thing for the world, but a challenge for the project. And one of the things that you'll see is a lot of these binary outcomes, there are very few there are very few yes examples. And so this is like, social scientists think about this as like a rare event outcome. Machine learning, they often call this like imbalanced training data, something like that. So there are a variety of techniques that are created to deal with this kind of imbalance, and you might want to explore some of those. Or you might not. It's up to you. Caregiver layoff. So this is whether the primary caregiver of the child was laid off. And then there was a question before from Lisa about things that are outcomes for kids versus that are outcomes for families. So here, one question is, if we are trying to estimate the effect of laying someone off from their job, we could measure it for that person, but we should also measure it for everyone around that person, right? There's like collateral damage when someone gets laid off, and so this will help us estimate the effect of that layoff on the kids. So that when we do, to make sure we're counting up all the costs when we think we're counting the costs. I think we're not counting all the costs now. So this is a question about being laid off. This is the distribution. Another thing is you'll see a lot of missing data. This is another challenge that you'll have throughout. We'll talk more about that in a second. Job training, whether you participated in job training. So you could imagine that job training is kind of the opposite. If you calculate the effect of job training, the benefits of job training, you only focus on the person who got the training, you don't focus on the kids, you're missing some of the benefit. So here's the question, here's the distribution. Okay, so now, this data set is a complicated data set that has been collected over the course of 15 years. It is gonna be a little bit hard to work with at first, especially if you're not used to working with social data. So for those of you who are not, there's gonna be weird things about this data, and a lot of social scientists, I think, will be more comfortable with it. If you are new to this kind of data and you have a better way of organizing the data, definitely let us know. We are happy to try to make the data easier to work with, and I'll tell you about some of the things that other participants have done to help make it easier for you as we go. But you should expect that you're going to spend a lot of time wrestling with the data and not a ton of time right away doing your fanciest neural net, right? As we all know, that's what a lot of research is understanding and working with data. So how do I know what these variables are? So we have some links up here. So this is the Fragile Families website. So if you go to this website, there's a tab here for data and documentation. There's documentation for each wave of the survey. Here's the year 9 page. You see how the survey is modular, right? This is the primary caregiver survey. This is the mother, this is the father, this is the child, this is the teacher. These are the scales. So remember I said some of these things, they ask a bunch of questions and then combine them into a single number. So for example, like depression. If you want to measure the depression of one of the caregiver, you can't search for a question that says depression because they don't ask you, are you depressed? There are standard scales that you can ask people about, I think, lack of sleep or loss of appetite, and then those are combined into a measure of depression. And that's described by this scales documentation. Okay, so for each of these, there's generally 2 things, the questionnaire and the codebook. The questionnaire is approximately like what the interviewer had. So it has, are child's foster parents related to you? Yes, no, you don't know. And it also has all this stuff here, which is like skip patterns. So for example, if the person says, for example, oh, the child doesn't know where the father lives, or doesn't know the father, let's say, is not in contact with the father now. Then they won't ask questions about, does the father read to the child? Does the father take the child to play in the park or whatever? So given what you say in some questions, you don't get exposed to other questions. And that's what all this kind of logic is. Again, very common in social science surveys. So the code book is different. So this is the questionnaire, this is the code book. The code book is roughly like a summary of the answers that people have given. So it has the variable name, a string describing the question, and a little bit of metadata about that question, and then some of the answers. So the question, so if you go back to here, this question is A3B. Very descriptive name. So here, this in the code book is M5A3B. So that stands for Mother Fifth Wave A3B. And so generally, you have the prefix for the type of questionnaire, you have the wave number, and then the question number. So common prefixes are mother or father, home visit, which is when they sent a researcher to the house and did observations of the house. So things like what was the environment around, were there like graffiti on the buildings, and also inside, were there exposed wires or all kinds of other things about the inside of the house. Primary caregiver, kid, kindergarten teacher, teacher. There were some child care surveys for the kids who were in child care. And then there's a full list in the documentation. And again, you'll refer back to this as you're working through it. This is an important thing. Some of the variables are constructed. So the variables, sometimes what you'll find is that working with the raw variables can be hard sometimes because there's missing data. And some of them, they should match up, but they don't always match up. And so the research team went and created these constructed variables, which are their best guess at what things are for this data, often by comparing multiple different answers and doing their best to eliminate missing data. So CM1F race is a constructed variable for the mother's wave 1 race and ethnicity, which is not necessarily what the mother said directly in the interview. So we think these constructed variables are a very good place to start. They have relatively little missing data, less than the others, the non-constructed. And these are ones that the Fragile Families team, who are domain experts, think are important. So if you are looking for a place to start, the constructed variables are a reasonable place. If you don't want to start there, that's fine too, but this is a reasonable place to start. So the wave number and the child age are not the same thing. So wave 1 to 5, the approximate child age is at birth, 1, 3, 5, and 9. So there's a lot of missing data in this data set, a lot. So there's a couple different reasons why the data could be missing, and this is information. These missings are not all the same. So sometimes people are missing because they basically drop out of the study. So you interview someone at birth, year 1, year 3, and then you can't find them anymore, or they don't want to be involved. So there's some people who drop out. There's sometimes that there's a skip because of the skip patterns. This is called a valid skip. So for example, if there was a question about drug use, have you ever used illegal drugs? And they say no, then you don't ask them, have you ever used marijuana, or have you ever used... So there you can imagine a very specific kind of imputation, because you sort of do know what they would say. But there are other kinds, whereas if they're not in the wave, you don't really know what they're going to say. Don't knows, sometimes people say don't know. How do you handle that? It's not clear. And refuse. So we have a whole blog post about missing data to help with that a little bit more. So one of the things we've noticed is that the way the data is documented has been different than the way a lot of the challenge participants would like to interact with the data. And so this is, again, not surprising. This is part of what happens when people of different backgrounds interact with the same data. One of the cool things that happens is you get to see things that you never expected. And so some of the computer scientists who wanted to work with the data wanted very different forms of documentation than what we just saw. And so Greg Gunderson, who is a student in Barbara Englehart's machine learning class here at Princeton, he went through and parsed these code books and created an API that you can query to get certain information about the variables. And so he then open sourced that, and you can go here and see what he created and how you can use it. And it's totally open source, so you can definitely make it better. So other students, Arshay Jain, Binda Kalra, and Kirti Agarwal, they're students at Columbia, I think in the data science master's program. They were in Jay Kaufman's class. They created this constructed variables data dictionary, so they were very interested in the constructed variables. They found the way that they were documented in the regular fragile families data documentation not to be how they would have organized it. So they've open sourced their way of organizing it. You can, again, build on that and make it better. They would be really happy if you did. Dawn Kaufman, who's a statistical programmer at OPR, who's also here today. She created a different way of interacting with the codebook. So she's parsed through the codebook and created a CSV file that you could then read into R or whatever analysis program you're using and interact with that way. Or you can search through it using a command line script. And so the information about that way of doing it is here on this link here. Jeremy Fries, who's a sociology professor at Stanford, he's created some code for people that want to use Stata. There's a couple of things about getting this data into Stata that he has worked out, and he open sourced that. And Steve McKay, who's a participant from the UK, is a sociology professor. He's released some scripts that help people who are using R. So all of these were participants just like you. They all then shared what they did so that other people can build on it. They would all be ecstatic if you took what they did and did it even better and open source that for everyone. And I also want to be clear that all of this stuff is not supported by the Fragile Families Project. This is stuff that's specific to the challenge and things that we're trying out, and this is separate from the official documentation. The official documentation is the official documentation. This is not the official documentation. But I'd be happy to answer any questions about this stuff too. Okay? So you've already, you have a question about this stuff?
Yeah, but you can keep going.
Okay. So getting the data, we've all already got the data. If you haven't, you're at least starting in the process, and you should have it soon. Now I'm going to talk about how to build your submission. So your submission should include the predictions that are formulated in a certain way, your code, and a narrative explanation. We have instructions there for how to do that. Then once you make your submission, you'll get up on the leaderboard. So if you go to codalab.fragilefamilieschallenge.org, you can see the leaderboard, which has all the scores from people so far. So what we've done is we've split the data into 3 pieces. We have 4/8 of the data is in the training data, 1/8 is in the leaderboard data, which is used to make a score here, and 3/8 is completely held out data that we haven't looked at yet. Also, we have a tradition in these Getting Started workshops that after you make your first submission to the leaderboard, you get a chocolate bar. This was an innovation that Ian started, which I think is great. So we have a huge bag of chocolate bars here. And so after you make your first submission, come and get your chocolate bar. Anyone who is watching on the live stream, if you make your first submission today, send me your address. I will mail you a chocolate bar.
Wait, is a submission a model that predicts each of the 6 outcomes?
No.
Oh.
So one of the things we've done is in the data that you will get, we've pre-populated your first prediction. So you could actually make a prediction before lunch. We basically filled it in with all the mean values.
Yeah.
So that's kind of a reasonable thing to do. So if you want to only focus on eviction, and you upload the mean values for the rest, and you've got your submission. Yep.
What are the loss functions that you're using to score these?
We're using mean squared error. Sorry, mean squared error. Yep.
Do we know the reliability of the scales used in the outcome variables?
I would say sort of. So there have been, the scales are documented in that file, and these are the scales that the Fragile Families research team thought were reasonable scales to use. I would guess they have been validated in some settings. I would guess the settings that they were validated in are not necessarily the ones that they're being used in. So I would say they are reasonable choices, but I don't think we know for sure the measurement error properties of them. But they're not crazy things to do.
We have convex alpha somewhere. It's not on the webpage, but we did put it at the beginning of this whole
Yeah.
Yeah.
But isn't that in the documentation?
I'm looking for it. I just
You mean that kind of, you mean like convex alpha, or you mean some kind of,
Like an actual quantified measure of reliability.
in this particular data?
Yeah.
Okay, I thought you were asking something different. So I thought you were asking about like measuring depression with this scale versus
No, I
comparing
meant,
to a
like,
doctor's
specifically
assessment.
on this data. how well does
Specifically
scale
on this
perform?
data, I think that might be in the scales documentation. We'll find out.
Okay.
So get on the leaderboard and get your chocolate bar. So why might you want to participate? If you remember before, I said getting people excited about participation is one of the biggest challenges of mass collaboration. So we hope you'll want to participate because you care about the goals of the project. And it's a good chance to learn new skills. Some of you said, oh, I don't know anything about machine learning. This is a good chance to try out some machine learning stuff if you want. Or maybe you're used to machine learning and you don't know anything about working with social data. This is a good chance for you to learn some stuff about how social scientists collect and document their data. You can also win prizes. So we described these here. So there was a question about, we have prizes for and so let me tell you what the prize is. The prize is a trip to Princeton University for a scientific conference. So what we're going to do is we're going to invite people that make make certain kinds of contributions to come here and share their work with others, with other part of the Fragile Families research team, and with the board of advisors for our project. We'll give these prizes for lowest mean squared error for each of the 6 variables. Also, we'll give them for innovative idea from a social science perspective and innovative idea from a data science perspective. And those will be awarded by the board of advisors. We'll look at the submissions, look at the narrative explanations, and give those awards. We also have an award for a foundational contribution, a contribution that makes it easier for other people to make contributions. So we've seen people who have made different kinds of documentation. You could imagine someone would make a contribution about like that, or something that would deal with the missing data, or something. So even if your contribution, contributions that help other people make contributions are contributions. Sometimes those are even the most important contributions, so we want to make sure those are acknowledged. And also some of the things that are the most innovative could be things that show things that don't work well, right? So there's a lot of techniques to deal with imbalanced data. If you could show really strongly that none of those techniques work, that would be a very important contribution, even if it doesn't have a high score on the leaderboard. Okay? There's also, this is a scientific process, so we publish the results so that other people can learn from what we've done. So we're going to have one paper where anyone who contributes a model that goes into this ensemble community model, those people will be co-authors on the paper. The exact details of that are still being worked out. That's the idea, and this paper should have hundreds of authors, we hope. That's optional. Like, if you want to be a co-author, and you make a good contribution, you can, but you don't have to be. It's up to you. Also, we're going to have a special issue of the journal SICSS. I'm the guest editor, along with Sarah McClanahan. And SICSS is a new journal that's published by the American Sociological Association. It's an open access journal. And the idea of this special issue is to give participants a chance to write their own paper about what they did, so that people can learn from each other all the different things that are tried. So we'd love it if some of you wanted to take what you've done in the challenge, write it up, and submit it to this special issue. So part of that is about honoring the contribution that you're making sure that gets into the scientific literature, and also it's about making sure that people in the future can learn as much as they can from all the effort that we've put in. So in the same way yesterday we focused on like documenting what we're doing because we know that that's going to be important to people in the future. Participating in this special issue, I think, is also going to be important to people in the future, and of course to you in the present. And then you should participate because it's going to be fun. So the timeline. The deadline to submit to the challenge is August 1st. That's when we'll stop taking submissions. Then October 1st is the deadline for the special issue. So, and then in the fall we'll have the scientific workshop. We haven't picked the exact date yet. So some quick advice. Get started with the constructed variables. That's a reasonable place to start. Another idea, this is now we're into sort of more advanced ideas that are probably hard to do just today, but might be possible to do in a week if you wanted to work on this in the second week here at the Summer Institute. So there are already hundreds of papers that have been written with this data by domain experts, people who are truly experts in this area. So how could we use all that information somehow to build our model? And it's very convenient that all of those papers are already collected into a database. So you can go to the Fragile Families website right here, and you can find all of those papers. So how would it be possible to extract all the wisdom from those papers and combine it or use it in a meaningful way? We don't know, but we would love to know how. That would be cool. If you could figure that out, that would be awesome. Use the structure of the data is another tip we have based on what we've seen. So a lot of times people see this data and they start thinking like this, like, I'm going to throw all these features into one big automatic feature selection thing. But this is ignoring a lot of the structure that's in the data, right? There's time structure. There's structure based on who's interviewed. And so taking an approach purely like this, you're not taking full advantage of what's in the data and what you already know about it. So we think some way of using this structure should be helpful, but we don't know actually the best way to do it. So another thing that we've seen is there seems to be some difference in like how people choose what variables go into their model. So one idea, some people seem to want to just throw all the variables in and then have some big feature selection thing make the decision. That doesn't seem to work that well in this setting because there's not an enormous number of cases. And there's all kinds of missing data, and there's all kinds of structure that's not really accounted for if you just use an out-of-the-box feature selection thing. So what we think will be a good approach is some kind of human-assisted automatic feature selection, but we don't know what that would look like. Or another way of expressing this is like human-assisted or like using some kind of automated system, some kind of combination of an automated system and a human system, and we don't know what that would be. As I said, some of the outcomes are rare, so you'll want to account for that, especially if you're doing the binary things, and there's a ton of missing data. So that's it. That's the Fragile Families Challenge. We would love for you all to participate and get your chocolate bar. So that's it. So now you can work individually, in groups. You can take a break whenever you need. And Ian and I will be here to walk around and help you. Dawn will be here as well if you're interested in working with the CSV file she created. And for those of you on the live stream, we'll be on the Google Hangout as well, so you can find us there. If you have any questions, you can ask us that way. So that's the Fragile Families Challenge, and I look forward to seeing what happens today, and then maybe in the second week as well. So let's get started.